Pre-statistics. Graphing square root functions. Lesson objectives. Sketch graphs of square root functions by hand and the graphing calculator. Explain the graphical significance of a, h, and k for the function y equals a times the square root of x minus h plus k. Lesson objective. We'll begin with the graph of the square root function, which we will call the parent function. We're going to use the graph of the parent function square root of x to make other square root graphs. Here we have our table of values. When x is -1, y is undefined because we can only take square roots of positive numbers. The square root of a negative number is not a real number. So when x is -1, there is no value for y. When x is 0, y is 0. Square root of 0 is 0. When x is 1, y is 1. The square root of 1 is 1. When x is 2, y is the square root of 2, which is about 1.4. When x is 4, the square root of 4 is 2. So when x is 4, y is 2. So we have this function here that's an increasing function, but it's not increasing as fast as an exponential function. This graph is increasing slowly. Using the graphing calculator, if we type in the square root of x and y1 and hit graph, this will be our parent function. And if we hit second graph, which is table, we get the same values we had in the table in the previous slide. Example 1. Compare the graph of g of x equals the square root of x minus 3 with the graph f of x equals x squared. So we're going to compare this graph to the parent square root graph. Solution. So here we have the square root of x. This is f of x in blue. It starts at 0 when x is 1, y is 1. When x is 4, y is 2. And if we make a table of values for g of x, we see when x is 0, g of x is square root of -3, which is undefined. Only when we get to 3 do we get a value of 0. So any numbers less than 3 are not in the domain for g of x. And if we look carefully, we see that really this is just the parent function moved over 3 units on the x-axis. So when y is 1 for g of x, x is 4. When y is 2, the x has been moved over 3 places. So let's think about it like this. F of x equals the square root of x. F of x is the same thing as y. Now if I wanted to solve for x, I would square both sides and I would get x equals y squared. So when x is 0, y is 0 squared, which is 0. When x is 1, y is 1 squared, which is 1. When x is 2, y is 4. When x is 3, y is 9. If we think of g of x, we do the same thing. We square both sides. We get x minus 3 equals y squared. Solving for x, if we add 3 to both sides, we have x equals y squared plus 3. So when x equals 0, this expression becomes 3. When x is 1, y squared becomes 1 plus 3 is 4. So this tells us the x values have been increased by 3. Or we can think of it graphically as a translation 3 units to the right. Lesson objective. Changing the value of k. Using the graphing calculator, if I graph the parent function square root of x and then the square root of x plus 2, And notice that the 2 is not inside the square root. Here we have our parent function. Here we have our new function. So we see that if we add 2 to the outside of the square root function, it shifts the graph up 2 units. Now sometimes this is hard to see on the viewing window, so if we look at the table of values, y1 is square root of x, y2 is square root of x, and then you add 2. So if we look at the values between y1 and y2, we simply add 2 to y1 and we get y2. So what happens if we take the square root of x and then we subtract 3? Here we have our parent function, and here we have the new function, square root of x minus 3. So now the y values have changed. They have decreased by 3. And we can see this in the table of values. For y1, when x is 0, y is 0. For y2, when x is 0, y is a negative 3. So looking at the graph, here's our parent function, square root of x. If I look at the square root of x plus 4, every single y value has been moved up 4. If I look at the graph of y equals square root of x minus 5, every single y value on the parent function has been moved down 5 units. So when k is positive, we move the y values up k units. So when k is negative, we move the y values of the parent function down the absolute value k units. So the absolute value of negative 5 is 5. So each y value goes down 5. Changing the value of h. So consider square root of x, and then consider the square root of the quantity x minus 4. This time, this is x minus 4 all within the square root. When we graph this, here's our parent function, here's the new function, and as we've seen in example 1, this has been a translation, in this case, of 4 units. If we look at the table of values, we can see that the x-intercept for our new function is 4. Anything before 4 is not on this new graph. For y1, when x is 1, y is 1, so this whole graph of the parent function has been moved 4 units to the right. Let's look at the example of the graph of the square root of the quantity x plus 5. Again, x plus 5 is all under the radical. This time, the parent function has been moved to the left 5 units. And if we look at the table of values, we can see that when x is 5, the square root of x is 2.23. But for y2, x is 0. So the value for y and y1 when x is 5 is the same value in y2 when x is 0, 5 units to the left. Thus, as h is a positive number, it's a translation to the right, and when h is a negative number, x minus a negative 5 is the same thing as x plus 5. The function translated 5 units to the left. So here we have our parent function. When h is 2, it's 2 units to the right. When h is a negative 2, which produces x plus 2, it's 2 units to the left. Changing the value of a. So if you recall, a is the coefficient that multiplies the square root of x. Let's consider when a is 3. Here's our parent function. Here we see 3 times the square root of x. So the graph is increasing faster than the parent function. And if we look at the table of values, we take y1, we multiply it by 3, we get y2. When y is 1, y2 will be 1 times 3, or 3. So these values in y2 are 3 times larger than the value in y1. If a is equal to 0.5, so here we have our parent function, here we have the new function 1/2 times the square root of x. It increases at a slower rate. And from our table of values, we see that y2 is half of y1. So y2 is growing at half the rate as the parent function. So here's our parent function, and when a is larger than 1, the graphs increase faster, and when a is less than 1, the graphs increase at a slower rate. Thanks for watching.